You probably see this number every single day. 20 degrees Celsius. Or maybe, for you, it's 68 degrees Fahrenheit. You glance at it, and you know what it means: a pretty nice day, maybe bring a light jacket. But what if I told you that number is more than just a forecast? What if it's a secret message from the past? A hidden code that tells a forgotten story of ambition, rivalry, and a complete rethink of how we measure the world. That little number, and the act of converting it, is a clue. It points to a time when temperature was, well, a total mess. There was no single standard. A hot day in Paris was frustratingly inconsistent with a hot day in London. Scientists couldn't easily replicate experiments. The world was desperate for a common language to describe something as basic as hot and cold. By the end of this, you won't just know why 20 Celsius is 68 Fahrenheit. You'll have decoded the formula that connects them and uncovered the story of two men who tried to capture reality in a glass tube. The man who hated negative numbers. Let's head back to the early 1700s, to a guy who was obsessed with precision. His name was Daniel Gabriel Fahrenheit. Born in 1686 in the city of Danzig, then part of the Polish-Lithuanian Commonwealth, he eventually settled in the Netherlands, a hotspot for scientific innovation. Fahrenheit was a physicist and a brilliant instrument maker, and he was seriously bothered by the messy state of thermometers. At the time, they were mostly unreliable novelties, not scientific tools. Fahrenheit wanted to create the perfect thermometer, one so consistent that any two of them would show the exact same reading. To do that, he needed a scale. A system. So he decided to build one from scratch. He started by finding the coldest possible temperature he could create in his lab, a frigid mixture of ice, water, and salt. That point, the absolute coldest he could get, he marked as 0. Why? Well, it was a practical choice. It meant that for most everyday weather, you wouldn't have to deal with pesky negative numbers. Next, he needed a reliable upper anchor point. For this, he used the human body. He set what he measured as normal body temperature at 96 degrees. Now, why 96? It's a handy number for an instrument maker, easily divisible by 12 and 2, making it simpler to mark smaller increments. And yes, his measurement was a little off from the 98.6 degrees Fahrenheit we know today. With these 2 points fixed, 0 for the ice, salt, slush, and 96 for human heat, the properties of water fell into place on his new scale. Pure water now froze at 32 degrees and boiled at 212. And just like that, in 1724, the Fahrenheit scale was born. It was a system built around the human experience of the world. For the first time, temperature had a reliable language. The man who loved simplicity for a while, Fahrenheit's system was the gold standard. The British Empire adopted it and, through its vast network, spread it across the globe, including to its colonies in America. But about 2 decades later, a Swedish astronomer named Anders Celsius showed up with a very different idea. Celsius was a man who valued logic and simplicity. He totally agreed that fixed anchor points were key, but Fahrenheit's scale just felt a bit random. 32 and 212? Couldn't there be something cleaner? So, in 1742, Celsius proposed a new scale, one based on the two most important states of the most important substance on Earth, water. He set the freezing point of water as one anchor and the boiling point as the other. And he decided there should be exactly 100 degrees, or steps, between them. This is where the original name centigrade from the Latin for 100 steps came from. But here's where the story gets a little weird, a human quirk in an otherwise elegant design. Celsius originally wrote his scale upside down. He marked 100 for freezing and 0 for boiling. Why on earth would he do that? Some historians think it was to avoid negative numbers during Sweden's cold winters, much like Fahrenheit had. If it rarely gets colder than freezing, your daily measurements would all be positive. It was a strange, counterintuitive system. Fortunately, it didn't stick. After Celsius died, other scientists, including the famous botanist Carl Linnaeus, began using and popularizing a reversed version. Water now froze at 0 and boiled at 100. This new system was clean, intuitive, and a perfect fit for the metric system that was gaining ground across Europe. Science had its new favorite language. Decoding the secret formula, and so, the world ended up with two competing systems, Fahrenheit's human-centric scale and Celsius's water-based scale. This is where our secret code finally reveals itself, in the formula to get from one to the other. That formula is Fahrenheit equals Celsius times 9/5 plus 32. Let's break that down. The plus 32 is the easy part. It's a historical echo of Daniel Fahrenheit. Celsius starts his scale at water's freezing point, calling it 0. But on Fahrenheit's system, water freezes at 32. So to get from Celsius to Fahrenheit, you first have to add that 32-degree head start. Now for the weird part, why multiply by 9/5? This is the ghost of Anders Celsius and his 100 steps. Between freezing and boiling, Celsius created 100 degrees. But on Fahrenheit's scale, the distance between freezing, 32, and boiling, 212, is 180 degrees. So, a Celsius degree is a bigger jump in temperature than a Fahrenheit degree. The ratio of the steps is 180 to 100. If you simplify that fraction, 180 over 100 becomes 18 over 10, which simplifies right down to 9 over 5. That's it. That's the whole secret. The formula isn't just math, it's a story. It tells us the two scales have different starting points, the plus 32, and different step sizes, the x 9/5. So when you see 20 degrees Celsius on your weather app, you can finally decode it. First, multiply 20 by 9/5. That gets you 36. Then, add Fahrenheit's 32-degree offset. 36 plus 32 is 68. 20 degrees Celsius is exactly 68 degrees Fahrenheit. The code is cracked. If you're enjoying decoding the science hidden in everyday life, do me a favor and hit that subscribe button. There are secret codes like this hidden all around us, and we're going to keep finding them together. Why we live in two worlds, so if the Celsius scale is so logical, why didn't everyone just switch? Why do places like the United States still cling to Fahrenheit? The reason is part history, part human nature. By the time the metric system and Celsius were being widely adopted, America had already been using Fahrenheit for a long time, thanks to the British. There was just too much inertia. In 1975, the US government even passed a law to encourage a voluntary switch to the metric system, but the effort was met with public resistance and eventually fizzled out. People are just comfortable with what they know. But there's another argument you'll often hear from Fahrenheit fans. For day-to-day weather, the Fahrenheit scale can feel more intuitive. Its degrees are smaller, giving you a bit more nuance without needing decimals. The scale from 0 to 100 also happens to line up pretty well with the range of weather in many places. 0 is very cold, and 100 is very hot. It's a scale that describes how the air feels to a person. Celsius, on the other hand, is often called the language of science. Its logical, water-based structure is perfect for labs and calculations. And so, we live in a world with two languages for temperature. When you travel or follow global news, you become a translator. That number on your weather app isn't just data, it's a cultural artifact. 20 degrees Celsius doesn't just mean 68 degrees Fahrenheit. For many, it translates a scientific unit into a lived experience, a cool, comfortable, mild day. Building a mental map now, you might be thinking, I have a phone for that. Why bother learning this? And that's fair. But here's a thought, as our tools get smarter, our own intuition can become more valuable, not less. Relying on a calculator for everything keeps us from developing a real feel for the numbers ourselves. This is why knowing a few key anchor points is so powerful. You don't need to memorize the whole scale. Just build a mental map. Start with what you probably know. 0 degrees Celsius is 32 degrees Fahrenheit, freezing. Time for coats and hats. 10 degrees Celsius is 50 degrees Fahrenheit, cool. You'll want a jacket. 20 degrees Celsius is 68 degrees Fahrenheit, mild and comfortable. Our perfect day from the start. 30 degrees Celsius is 86 degrees Fahrenheit, genuinely hot. T-shirt and shorts weather. With just those 4 points, you've built a framework. You can estimate everything in between. When you see a forecast for 25 degrees Celsius, you know it's halfway between comfortable, 68 degrees Fahrenheit, and hot, 86 degrees Fahrenheit, so it's going to be pretty warm. You're no longer just converting, you're understanding. You're thinking in both languages. There's even a great shortcut for estimating. Just double the Celsius number and add 30. For 20 degrees Celsius, that gives you 70 degrees Fahrenheit. It's not exact, the real answer is 68 degrees Fahrenheit, but it's incredibly close for a quick mental check. So, the next time you glance at your weather app, remember the story buried in that number. Remember Daniel Gabriel Fahrenheit, trying to build a scale based on the coldest thing he could make in his lab. And remember Anders Celsius, with his beautifully simple 100-step scale that he accidentally invented upside down. That number, 20 degrees Celsius or 68 degrees Fahrenheit, is a bridge between two minds, two philosophies, and 2 centuries. It's a monument to our ongoing human quest to measure the world around us. Because the scales we invent don't just measure reality, they shape how we see it. The secret code in your weather app was never about complex math. It was about a very human story of trying to turn a feeling, hot, cold, and everything in between, into a number we can all understand. What's the first temperature conversion you ever memorized? Let me know down in the comments. And if you enjoyed uncovering this piece of hidden history, be sure to like this video and subscribe for more deep dives into the science of everyday life. Thanks for watching.